This conference will now be recorded.
Hello, everybody. Jordan Girth here with the National Weather Service Office of Observations. Thank you for joining us for the Satellite Book Club Seminar Series. This is session number 175. The presentation today is a case study from the Hazardous Weather Testbed 2023 Satellite Spring Experiment. I'm glad to have our presenters today, Alex Edwards, lead forecaster from the National Weather Service Forecast Office in Tucson, Arizona, and Stephen Shiveley, meteorologist from the National Weather Service Forecast Office in Tampa Bay, Florida. Our discussion following their presentation will be facilitated by Nick Carletta, lead forecaster at the Weather Service Office in Minneapolis, Minnesota. So we've got all parts of the country covered today. One quick reminder before we get started, if you will be attending AMS next week, please stop by the Tower S posters on Tuesday, January 30th from 3 to 4:30 p.m. and Thursday, February 1st, also from 3 to 4:30 p.m. in Hall E. We will not be having a Satellite Book Club seminar next week virtually. So our next Satellite Book Club will be in 2 weeks, but we will be at AMS, and for those of you able to travel, look forward to seeing you there. All right, so let's go ahead and get into the reminders for this session. As you just heard, it's being recorded. There will be an opportunity for Q&A after the presentation. Please post your questions in the chat, and we'll field them in the order they are asked. If you have not signed in with your full name, please note your full name when asking a question in the chat so we can follow up if necessary. Also, we're always looking for future presenters. Kashad Bowman and Emily Maddox would love to help you repurpose your AMS presentation or maybe some other presentation that you recently gave. I'd love to include it in the Satellite Book Club if it is related to the topic. And the training team can help create training materials that may be unavailable. Ross Van Til can help with that. I'd like to thank our Tower S team, Kashad and Emily, the Office of the Chief Learning Officer, the GOES our JPSS program, our presenters, facilitator, and all of you for being with us today. Without further ado, I'd like to introduce Alex and Stephen. Alex Edwards, as I mentioned, is a lead meteorologist in Tucson. Before arriving in Tucson this past September, he spent the previous 6 years at Bismarck. Alex worked for several state and private meteorology entities in North Dakota and Idaho prior to joining the NWS. And Stephen Shiveley is a meteorologist in Tampa Bay. Prior to that, he was a TV meteorologist for 4 years, forecasting for Middle Georgia and the Delmarva Peninsula. However, he started his meteorology career in the Air Force, where he forecasted the weather for both Korea and Japan. He received his meteorology degree from Embry-Riddle Aeronautical University in Daytona Beach, Florida. Alex and Stephen, welcome to the book club.
Thank you so much. I appreciate it. I'm going to be starting the presentation today, and Alex is going to jump on a little bit later on in the presentation. So let's get started since the introductions were already so great. So really quick overview. We both attended the Hazardous Weather Testbed, the satellite proving grounds in May of last year. So as a reminder, when we talk about all these storms, it was a little while ago. It was around May 22nd of last year when we start looking at satellite and all the hazardous weather we'd be talking about. But the products we reviewed during the test bed was the ProbSevere version 3. Currently on AWIPS, we're looking at version 2. The probability of severe lightning casts, the Octane Speed and Direction Sandwiches, the new caps temperature and moisture profiles, and the PHS model. We were looking at all those, but for this presentation and for the decisions we made during radar operations, we're going to focus more on the ProbSevere version 3 and the Octane Sandwich. So really quick overview of both products before we get into everything else. So the Octane Sandwich is an optical flow code for tracking atmospheric motion vectors and nowcasting experimental speed and directional sandwiches. It highlights motion in the visible band, and the sandwich product combines speed and direction. So this was a really useful product we found during the experiment. It's something that actually took us a little while to get used to looking at. But you can see the image on the right here is a very good example here in motion. You can see we've got a lot of cluster of storms there developing all at once. But because of the shear is colored now, we're able to spot these storms that have those higher amounts of shear, which indicate storms that might be or are severe at the time. So it helps us spot these storms a little bit quicker. And that's kind of the first bullet point we have there. It can highlight convection initiative and shear. It can highlight motion gradients with cloud top divergence or vorticity, which is very helpful to us. And it shows mesoscale jets features missed by sparse systems. So the other thing we looked at is version 3 of ProbSevere. I mentioned it very briefly. So if you're familiar, obviously, with AWIPS, we're looking at version 2 in AWIPS right now. So this is kind of the updated version. It's using new machine learning algorithms. It also now includes the HER model, GO16 GLM, GO16 ABI, and additional MRMS data. We were actually the first test bed to test ProbSevere with the HER data, which made it very useful and helped make it a lot more accurate. And version 3 is more skillful and better calibrated. But it was interesting because of this, the percentages were actually a little bit lower than what you'd expect. So for calibration reason, for version 3, you have to look more in that 40 to 60 percentile instead of that 60 to 80 percentile you would look in version 2. We'll go a little bit more into a couple of the other reasons why version 3 is a little bit better and what helped us a little bit long in the presentation. Don't want to get too far ahead of myself here with some of these things, just trying to introduce the products we were looking at. So now we want to do a little setup of the day of what we're looking at weather-wise. So this was just 2 quick screen captures. We're not going to talk too much into the setup weather parameters for the day, but just really quick, we had about 1,500 to 2,000 joules of CAPE and about 30 to 40 knots of bulk shear in eastern New Mexico. And that was kind of our area that day that we were focused on for the severe weather and where we were planning on using these products and maybe issuing practices, watches, and warnings with them. And this was SPC's graphic for the day, and they were looking at pretty much the exact same area with that enhanced risk over that area with a 5% chance of tornadoes, a 15% chance of seeing wind, and then we actually had a hashed 30% chance for hail across that area. So it was definitely supposed to be the most active area for the day across the nation. But what made this more challenging and what actually helped do the test bed for the satellite a little bit more is radar data was very sparse. You can see the big radar that was supposed to help us that day, KFDX, was actually out of service that day. So because of that, we had to try to use neighboring radars, but you see the image there on the left, which I'm about to switch over to give you a better view of what we're looking at. So right in that middle of that enhanced risk was right where this circle is right here. And you can see once you take that one radar out, you have little to no radar coverage in that area. So because of that, we did have to lean on the satellite products and that ProbSevere when we were looking at the storms developing for the day. So now I am going to pass it on over to Alex to talk more about the storm development.
Yeah, sure. Thanks, Stephen. This is a good highlight of the surrounding radars that were previously shown that were that were available at the time. We're currently in Albuquerque's forecast area, but the Albuquerque radar itself has the deficiency there of terrain to the east that's causing some major beam blockage, and of course they have that the radar out east of their FDX that should have been helpful. That was down for the day. So there was essentially a data denial case that we were able to work during our case for the day at the HWT. The surrounding radars that would be of use were probably the next best radar was Amarillo, well to the east there, and then Pueblo, which is Cape PUX there, even further away though, and that's to the north. So those are the kind of the radars we had available at the time, but really nothing ideal for sure between Albuquerque being completely blocked by the terrain, Amarillo still about 100 miles away from the area we're looking at, and that came out to about 12 to 13,000 feet for the 0.5 degree tilt from that radar, and Pueblo obviously even further away at about 180 miles away with a base tilt at about 30,000 feet. So clearly not the best day for even lower level radar interrogation. We can move to the next slide. Okay, so even though we had some hints of storms developing where those red circles were in the previous slide, our better hints or better signals were coming from visible satellite and the products that were built off that. One thing that helped that day is that we were getting minute by minute scans from the GOES mesosector. So 1 minute data was helping giving us additional data and as well as additional lead time as we could kind of see the signs that were developing ahead of the sparse radar data that we were getting. Several different things that we were seeing initially, even before the storm had fully matured, was a strong above anvil cirrus plume already developing from this strong updraft, as well as a hint of the storm top divergence signal, which was being implied by the Octane product as well. This Octane product was showing the differences in the storm top directions and speeds as the storm top went up shear or down shear from the updraft itself. So we were starting to see hints of that even before this storm had fully matured. We were seeing definitely strong signs of a good strong updraft before we had radar coverage of it. We can move on to the next slide. Yeah, so we'll look at a couple radar scans now. 30 minutes after the previous radar images. This is the Albuquerque radar. Still, that beam blockage is blocking out most of what we could see in the low to mid levels. Maybe at this point we would get some higher level scans with it as the storm truly became stronger, but we weren't really getting anything useful out of it. We can go to the next slide. It might be a slow connection. Oh, there we go. So then this is Pueblo, obviously the furthest radar away in this kind of grouping around our area of interest, and where we do have storms to the north. The area we're looking at is just near that east to west interstate. That's I-40, I believe. And you can see there's like a kind of a washed out reflectivity signature with maybe some decibels, dBZs up to about 40, but nothing crazy of note. But it's just that area just north of the interstate that we're looking at. We can move to the next slide. All right, better coverage from Amarillo, this area just north of the interstate near the New Mexico and Texas border. So there's definitely some sort of, intensification in the reflectivity going on that we were watching, but didn't really have a strong reflectivity organization signature. The 50 dBz signature wasn't really there. Maybe the little hints of it. Even the shape of the reflectivity wasn't, strong in a way that made us think severe weather was imminent at that point if we were just looking at the radar itself. We can move forward. We did zoom in though, and looking at the mid-level tilts of the Amarillo radar, and even though the reflectivity core hasn't quite intensified or shown up, we were seeing the storm relative velocity signature of a mid-level rotation, maybe mesocyclone development in the mid-levels. We were talking about, the environment of good deep layer shear, good instability. So we do have this storm developing that has not quite the reflectivity signature that you would like to see yet, but there's clearly some sort of spinning in the mid-levels going on. So maybe some developing organization finally showing up on the radar data itself that we weren't seeing earlier. So this was kind of, tipping our, giving us little signs that maybe severity is around the corner or developing at that moment. Next slide. So jumping back to the satellite views at this time, this is just about 10 minutes after that previous radar image. We're getting strong signatures from the visible satellite and the products coming out of that, including Octane here, what you see. The image on the left is showing the directional differences in the flow of the storm tops there. So from the overshooting top that you can see a difference in color to the north and then to the south of it as you're getting flow out in different directions from the divergence. And then you can definitely see that as well in the image to the right, where you're getting differences in speed as you look up shear versus down shear. So up shear, you're getting flow back into the mean wind. So the speed that it's tracking relative to the kind of motion of the storm and the mean wind is slower than the reds that are showing up down shear as the anvil is getting kicked down shear away from the storm itself. So definitely a sign of divergence, strong storm top divergence aloft within or around that updraft itself. I will say this is like a bit of a qualitative analysis, but after a few days of using this product at the HWT, it was a bit easier to become calibrated with what was becoming strong and not. And certainly that octane speed, the differences in colors you see there as the divergence is showing up, really highlighted the potential or just how strong this updraft was, even without the radar signatures that were showing up initially. And you can also see the above anvil cirrus plume as well a bit there if you squint. Okay, next slide. Okay, at this point, the red circle is where that storm we're looking at. The Albuquerque radar is still blocked by the terrain. The Pueblo radar is still pretty far away and doesn't look too impressive. Maybe on the Amarillo radar, we're getting to see a bit more structure and just in the reflectivity as it kind of consolidates up and maybe becomes a bit more organized. I think we'll zoom in here if we go to the next slide into the Amarillo radar. Yeah, so this is the Amarillo radar again, zoomed in. Maybe we're getting a bit better structure in the reflectivity itself. If we looked aloft, the 50 dBz is starting to show up a bit more, but we're definitely getting in the velocities, more signs of that rotation that are showing up within the strong updraft, even though we haven't quite gotten the reflectivity cores that would signify, imminent severity quite yet. So that's where we're at this point at 2220 Zulu. You can go to the next slide.
All right, I'm going to take it back over for this portion. So after analyzing satellite and analyzing radar, we were able to focus in on this one storm. And that's what I think we all got away with from this experiment, is the Octane was really good at. And when you're looking at a cluster of storms, which ones you need to really focus on or dive a little bit deeper into, because you could see that shear and the stuff aloft, the wind direction and the shear, and you can see those big updraft cores and which ones you need to focus on. So this one really piqued our interest right away because we know we weren't seeing much in radar, but you can see here, this is a great sampling of ProbSevere 3 versus ProbSevere 2 here on the right-hand side. Actually, I think I've got it's going to circle if I do this again. Let's see. Yep, there we go. You can see for ProbSevere version 3, this uptick in the last 10 minutes or so, while version 2, I guess we call it the older version, though it's the one we're currently using. You can see it staying pretty steady. And we were curious at the time, we kind of agreed that, ProbSevere version 3 is probably more accurate because of what we were looking at. But this is a great thing about these HWT experiments is we're wondering how ProbSevere caught onto this when ProbSevere 2 was not. And that's what's great is we can literally turn our backs and talk to the experts who created these products and figure out what the difference was. And the difference was the one thing I kind of avoided talking about at the very beginning because I kind of didn't want to ruin the back end of this presentation. But it was satellite growth and intense convection probability. So ProbSevere version 2 really doesn't account for satellite growth, while version 3 does. And with the missing radar data we had for that day, this was really the tipping point, especially for us to think about a severe warning, but also for version 3 compared to version 2. looking at that possibility of severe weather. With that satellite growth, you can see it here in the chart, the timetable going through the last 30 minutes. So you can see that growth rate increasing very rapidly with this system. And that's what, if I go back a slide, that's what version 3 saw. That's what it was hinting at. That's why it decided to start bumping those numbers up, or that chance for severe weather up. While version 2, which didn't have that satellite growth in there, all it was really looking at was radar, which we've seen in the last 5 or 10 slides, we didn't have much. So because of that, version 2 struggled, while version 3 was able to catch on a little bit better because it was looking at that satellite growth. So I was really impressed with that. And that's really what helped us make our decision. So if you're not familiar with the HWT experiment, not only are we playing around with these products, we act like an office. So we're analyzing, and we're also able to issue watches and warnings internally as we're doing this. So with all the products that we looked at, you kind of went through the whole process with us that we went through that day in May. We saw that Octane storm top divergence signature. We saw the infrared thermal coupling, the above anvil cirrus flume. We saw the convection probability product, the ProbSevere version 3, and the radar mid-level rotation signatures. All those things combined gave us enough confidence to actually issue a severe warning on the storm. And personally, if it wasn't for the Octane and the ProbSevere version 3 and these other satellite products that we were able to look at, the radar signatures of itself, you were just looking at the radar images, I don't think we would have had enough confidence to issue a severe at that time. So I really think these new products that we looked at, especially the Octane Speed Sandwich and Shear, and the ProbSevere version 3 was extremely helpful. It increased our confidence, which is what they're supposed to do, to issue that severe for that area that we've been looking at throughout this presentation. And I think we'll throw it over to Alex one more time as kind of a wrap up of what actually happened afterwards.
Yeah, Stephen. These are the warnings that we ended up issuing out of this thunderstorm. You can see actually it went through a nice split there too. So both of those cells came out of that same cluster. This is just a smattering of the different radar-based products that we were looking at. But you can see, like the top right, the MRMS mesh, the maximum estimated size of the hail, that green and higher in there is really the above 1 inch indicator. So there was definitely an intensification that happened. This is 20 minutes after the warnings we put out. So the storms did move a bit further east, so maybe a bit better sampled by the Embry-Riddle radar, but really what came out of it was finally the kind of organization that we were seeing hints of 20, 30 minutes before playing out here. And then in the next slide, we can see what actually happened in the real world in regards to impacts at the surface. Reports from these cluster of storms included 3 brief tornadoes, over 20 hail reports topping out at about 2 inches, 20 wind reports topping out at a wind gust of 92 miles per hour. So plenty of severe reports out of this. And something we didn't touch on quite as much in here, but it's noteworthy that the Prob tornado and the ProbSevere version 3 had topped out with a much stronger tornado probability than version 2. That was towards the latter portions of this storm cycle, and we were mostly focusing on the earlier side of it during our operations at the HWT. But it was interesting to note that the Prob tornado version 3 came out with a much higher probability at about 47% compared to 9% from version 2 in these storms that ended up producing tornadoes themselves. And I'll add a reference to this at the end, but John Centennial, who was from SIMS at the University of Wisconsin-Madison, was there as the developer of this ProbSevere product, and had made the kind of hypothesis or conclusion that since the ProbSevere version 3 was including the HER data, that HER data had actually captured the low-level shear and low-level SRH maybe better than the RAP did, which was being fed into version 2. And the RAP kind of environmental data for that moment was at a much lower magnitude than the HER. So possibly that's what caused the much higher probability, and then kind of how it worked out with the tornado reports there. So we can advance forward. So really the overall takeaways here is that the tools we were using in this radar data denial case that we ended up with allowed us to give lead time and almost a heads up internally, and then that turned into a heads up what would have been externally in our simulated case. This lead time via the storm top divergence signatures via the Octane product, which really highlighted how strong that storm top divergence was. There was also an IR thermal couplet that showed up that we didn't show here. And then of course the above anvil cirrus plume that also showed up. But really Octane gave us that first sign of something going on there. And then subsequently, ProbSevere, the new version 3, comparing that to version 2, rose up to about 35% at the time that we decided to issue the warning for a severe warning. And we had in mind that that model was lacking a strong reflectivity signature due to the data denial of the radar outage. So it gave us, a little bit of an extra push to put a warning out before we had seen a strong 50 dBz core, for example. And it gave us the lead time that's could be useful in the real world. So really combining these products, the minute by minute data that was coming out of the mesosector, and then how Octane came out of that in ProbSevere version 3 really gave us confidence to produce a warning in the simulated case that I'm not sure we would have without them. And so that was the big interesting takeaway from this day. I think the last slide has a couple references and a thanks to John Centennial and Kevin Thiel at the Satellite Proving Ground HWT for their assistance. But that wraps up what we have here. So thanks.
All right, thank you for that presentation. Before we move on to any of the discussion, I do want to quickly bring up the fact that due to the AMS annual meeting coming up next week, there will not be a satellite book club, but please join us again on Thursday, February 8th, where there will be another satellite book club where Pam Sullivan, the director of the Office of Geo Observations, will discuss GOES R to go to GeoXO, NOAA's geostationary satellite systems today and through 2050. So if you want to know some more about what the long-term plans are for the geostationary satellites, please join us on February 8th. And if you ever have any questions about this entire book club or anything else regarding the products shown today, or even if you would like to present yourself, please contact Kashad or Emily at the email address that is listed here, and they can provide you with any of the help with that, whether it's a question or anything else. And in addition, for those of you that have access to the NWS Slack internal page, you can join the Towers S channel in there where additional discussions can happen. All right, so I believe at this time now, we will have our discussion. So if you have any questions for our presenters here today, please make sure to send a comment through our chat. Or if you would like to, we can also have you say it verbally if you would like to request an unmute. So I'll give some time now to see if anybody wants to type anything in. And if not, I can try to ask a couple questions to get things started. So our first question here today is from Kevin Thiel. He says, great presentation. Thank you both for taking your time to show this case from the testbed. Since you are working with limited radar data fed into MRMS, did that change your interpretation of the ProbSevere version 3 thresholds and trends?
Kevin, yeah, I think it really did. At least the thresholds anyway. I think the trend stood out to us as notable, one way or the other, that it was jumping up as we were seeing these other signs. But in our discussion as we were working, I think we came up with the idea that there should probably be a lower threshold. We didn't know what that lower threshold would be, but since it was missing, a healthy kind of radar input, we thought, well, it's jumping up, and we don't think it'll, the probability will get crazy or anything, but the fact that it's increasing the way it is, it did that allowed us to make that decision at a lower probability. So it was definitely something that was in mind for us and changed our kind of internal threshold for issuing a warning.
Yeah, Alex pretty much covered everything. Yeah, I mean, I agree. I think we saw the trend jump up, and with the lack of radar data, I think we figured out that those percentages weren't going to get too high until it got into better radar coverage. So just seeing those trends bump up, and I was honestly surprised version 3 had the percentage as high as it was with such the limited radar data that we were looking at the time.
All right. Well, while people are thinking of their own questions, I'll throw a question of my own in here. So since you were at the HWT and did this experiment there, has that changed how you've gone back to operations at your own offices?
I think it has. Oh, I'm sorry.
Go ahead.
Okay. Yeah, I do think it has a little bit. If it was up to me, I'd already have the Octane Speed Sandwich and stuff in AWIPS, because we were able to kind of manipulate the color table a little bit more and be able to spot stuff a little bit easier. But I have been using the online version, and it does help me pick out a few things. I feel like I've leaned more into looking at the version 3 of the ProbSevere. I tend to have, obviously on our AWIPS, on our MRMS, I already have version 2 up and running on AWIPS. Then I'll normally have version 3 on my desktop computer kind of sitting beside me too, and I can glance over at both of them rather quickly. But I've definitely started incorporating at least those two products. It's been honestly a little bit easier to do the ProbSevere version 3 than the Octane, just because we're not in AWIPS with those things yet. But it's definitely helped with some decision making processes, I think, since I've been back.
Yeah, I don't know much to add. Pretty much the same. I think we were able to add version 3 of ProbSevere to GR as a place file, and I thought I had seen it already in AWIPS later in the season, and I'm talking about my old office in Bismarck, but I'm not 100% sure about that. I was already a big fan of ProbSevere as it is, so going forward, I think just working this case has given me increased confidence in how it interprets, brings in the intense satellite kind of growth, that probability, and then also the HER model environmental data.
And then one quick follow-up question on mine, last one there is, I know personally as a big user of the ProbSevere products, one that's helped me out a lot with is kind of some of the more pulsy convection. Since you both talked about you've used in operations after the HWT, have you been able to see how version 3 performs compared to version 2 in those more borderline severe cases?
I haven't been able to compare as much. We had a slower season in last summer, and especially in the borderline cases. I'd like to go back and look. I think at my experience at the HWT, I believe this was last year now, but I believe it was picking up on it a little bit better, perhaps, and maybe that includes that satellite growth as well. But I'd have to kind of gather more cases internally to figure that out myself.
Yeah, I will say, for me in Florida, almost every severe weather case is kind of borderline for the most part, especially during our summer convective season. But I've seen version 3 kind of working the same way it worked in the experiment, where it tends to pick up on the storms maybe a scan or two earlier. you'll see that uptick, a little bit earlier, and that's kind of helped me out focus on those storms maybe a little bit earlier than maybe version 2. And I do think that has to do with, that satellite input being in there, seeing that divergence and seeing that satellite growth before the storms actually develop. Because at least here in Florida, it's pulse. It'll pop up. It'll be a severe storm for 10 minutes and then it's gone. So if you don't get a hold of it early, then you'll miss out. So I have noticed it's helped me find the storms a little bit earlier.
All right, thank you. Our next question is from Jason. He has 2 questions, so I'll start with the first one here. So, did the lack of radar data change your interpretation of ProbSevere at all?
Yeah, I think we had the idea that the missing reflectivity or just in general missing radar data would give us lower thresholds. We didn't know exactly what that threshold would be, but we definitely kept it in mind. So I think that's what allowed us to pull the trigger a little earlier than the previous threshold in mind would have allowed.
Yeah, and I agree with Alex. That was pretty much it. We knew we weren't going to get those higher thresholds because of the missing radar data. So we were looking at more trends than, hitting an exact percentage or hitting an exact number for the ProbSevere before issuing something.
All right, thank you. I'll move on to his second question then. He also said, do you think that your decision making would benefit from a cloud top divergent product from Octane versus trying to interpret the speed gradients?
I think I would say yes. I had mentioned we were becoming better calibrated by doing this every day, but in real world, I probably wouldn't have daily, cases that I would be looking at to become fully calibrated with it just based on color. So something that could be quantitative, and then have maybe some sort of internal threshold, whether it's written down, for example, a number that's based on numbers to go to would be hugely beneficial. Because if I sat down with the same product today, I think I would need a little while to figure out what the stronger kind of how to interpret the image like I did, a year ago, basically.
Yeah, I agree with Alex. I mean, that would be extremely helpful. And like I said, we got a few days to test it out. And like I said, I mentioned it briefly, I think in mine that, I was able to get an AWIPS and kind of mess with the color table a little bit and kind of make it so it's easier for me personally to look at, read. That helped out. But like you said, you have a quiet season for a few months, no storms, and then you pop back into it again. I still think it'd be a little bit of a learning curve. But if we already had that divergent product in there, it'd definitely be extremely helpful.
All right, thank you guys. We have one more question here. The next one's from Mike. He asks, were any specific values in the satellite product identified that one could look for, or was it mostly qualitative?
The Octane images were mostly qualitative. We were able to see the trends in the graph from the intense. I can't remember if you go to the satellite intensity from the ProbSevere, that slide. Oh, yeah, that one. So this kind of the satellite growth, the intense convection probability that was being fed into ProbSevere version 3 did allow us for values, or at least a trend that was, we could actually see and track rather than kind of looking at the overall gradient of colors. So this went hand in hand, but I think if there was a way to kind of have a parameter out of what we were looking at in Octane, that would also be helpful.
Yeah, I agree again with Alex. Like I said, I think a good image of what instead of going through 18 slides, I'm just going to do this. This animated version, I think is a good example. We don't have exact numbers right here. We don't know what the numbers are, but you could see pretty quickly which storms are we're seeing here that highlight. And you can even see one I didn't put an arrow on. You can spot it down here in the far right corner of your screen, another storm. So I definitely think it was more qualitative, and we weren't looking at exact numbers as much as once you got this color table calibrated really well, you could really see that storm top divergence and that shear pretty evidently, and we were able to kind of highlight and watch those storms a little bit more carefully.
All right, thank you. I think we might have time for one more quick question if anybody has something. All right, I'll ask one final question to wrap us up then. So how do you think Octane Speed Sandwich can help during severe weather operations?
I think we've kind of, oh, sorry, Alex. I guess you've been going first.
Go ahead.
Okay, but yeah, I feel like we've kind of been talking about it throughout this presentation, but I really think it's helpful, like in this example here. It definitely highlights the storms you need to focus on more, and you kind of saw in our example too that, you know, we were able to use Octane, and then ProbSevere would catch on to it afterwards, and you know, or around the same time. But it's definitely helpful in severe operations. We're expecting, you know, a big severe weather day. There's a lot of thunderstorms out there, and you need to know which ones to focus on, and which ones you could potentially see getting worse over the next 10 to 15 minutes. I really think it helps in that situation.
Yeah, at the very least, I was thinking it's definitely good situational awareness. Maybe getting the kind of quantitative part of it might be a little more difficult with just using the colors, but like it really highlights the most intense convection that you're seeing across your area. So at the very least, it gives me a heads up in a way that maybe just looking at the visible satellite in grayscale might not. And like Jason just put in the chat there, I've definitely looked at it when available at times in that Sierra slider page, which I'm a big fan of.
All right, thank you. And with that, that's all the time we have today for questions. So I will pass it back to Jordan for some concluding remarks.
All right, thank you so much for that great presentation. Really appreciate you, Nick, for facilitating the discussion. And Alex and Stefan, that was really great content. Thank you for sharing the experience of the at the Hazardous Weather Testbed last year. As has already been stated, we are on the road to GeoXO, stopping at Goes U launch on the way. So join us on Thursday, that's 2 weeks from today, February 8th. Pam Sullivan, Director of the Office of Geo Observations, is going to talk to us about the satellite systems today through 2050 from geostationary orbit. In the meantime, if you have any questions for the Tower S team, we are standing by. Kashawn Bowman and Emily Maddox can address any questions that you have. Please find us in the Tower S channel on the NWS internal Slack space. And with that, we'll wrap it up for today. Thank you so much for attending, and see you again in 2 weeks. Take care, everybody.